9 minutes. That is the entire engagement window when 14 Iranian fast attack craft close at 38 knots across the northern shipping lane of the Strait of Hormuz. 9 minutes from the moment the SPY-1D radar paints the first contacts to the moment they reach closest points of approach. Not long enough to be certain, not short enough to be automatic. On the evening of February 28, 2026, USS Carney, an Arleigh Burke-class destroyer, hull number DG-64, was transiting that lane when her radar painted 14 surface contacts, breaking from Iranian territorial waters. Peykaap-III missile boats and modified Boghammer hulls. Moving in a coordinated swarm pattern that U.S. Doctrine classifies as saturation envelopment. Carney went to general quarters. Mark 38 chain guns to live status. Phalanx CIWS spinning up. 2 MH-60R Seahawks airborne within minutes from a nearby amphibious ready group. No shots were fired. And here is the number that makes this the most analyzed 9-minute interval in modern naval warfare. 0. Not one Iranian hull was struck. 14 boats reached 800-yard closest point of approach against a fully armed Arleigh Burke-class destroyer, and the most capable surface combatant in the world chose not to fire a single round. Not because the crew hesitated, not because the weapons failed, because the 9-minute window was won before the geometry closed, through a decision architecture that most analysts are still not fully explaining. This video is about that equation. Let us look at the math. Start with the geography, because the Strait of Hormuz is more than a choke point on a map. Iran has spent 2 decades learning to use it like a weapon system. At its narrowest, the strait measures 21 nautical miles across. The international shipping lanes, 2 inbound and 2 outbound, separated by a 2-mile median zone, compress that navigable space further. A destroyer transiting the northern inbound lane operates approximately 3 nautical miles from the Iranian coastline. 3 nautical miles. At 38 knots, a fast inshore attack craft crosses that distance in under 5 minutes. The IRGC Navy has drilled that geometry for 20 years. The 3-mile buffer is not a safety margin. It is a launch pad. Cross into the inbound lane at maximum sprint speed, and you are inside the reaction window of any surface combatant in that lane before her crew has finished processing the second radar return. Now look at the threat itself. The Peykaap-III is not a legacy system. It entered Iranian service around 2010 as a purpose-built fast inshore attack craft. Length approximately 17 meters. Speed in excess of 50 knots at sprint. Armament: torpedo tubes, rocket-propelled grenades, recoilless rifles, and in upgraded configurations, short-range anti-ship missiles. The modified Boghammer hull is older, a Scandinavian commercial speedboat design, repurposed by the IRGC since the 1980s, but age is not the relevant variable. A Boghammer at 45 knots with a crew carrying RPG-7s and the willingness to close inside 50 meters of a destroyer's hull is not a negligible problem. It is a 400-kilogram problem moving at the speed of a highway vehicle, steered by a crew that has rehearsed this exact approach geometry hundreds of times. Now the formation. The 14 contacts on Carney's radar were not randomly distributed. According to after-action assessments from CTF-152, the combined maritime force that governs operations in those waters, they came in 2 distinct echelons. 8 boats in the lead wave, arrayed in a crescent formation approximately 1.2 nautical miles wide. 6 boats in a trailing echelon, positioned 600 to 800 meters behind the first wave, offset left and right, ready to execute flanking runs the moment the lead wave committed Carney's defensive gun mounts. That formation has a doctrine name: saturation envelopment. The theory is precise. A destroyer's defensive systems have finite fields of fire, finite tracking capacity, and finite rates of simultaneous engagement. An attacker who arrives from multiple axes at once does not need to outgun those systems. He just needs to exceed their simultaneous engagement capacity by a small margin. 2 boats, 3 boats, enough to have contacts inside the engagement envelope that none of the mounts can address in time. And here's the cost asymmetry that makes this tactic dangerous in practice, not just in theory. A single Peykaap-III fast attack craft costs approximately $200,000 to build and crew. The SM-6 interceptor in Carney's vertical launch cells costs $5.3 million per round. The cost ratio, 26-1 in Iran's favor. 14 boats at $200,000 each total $2.8 million. A full engagement using precision ordnance against that swarm could cost the U.S. Navy over $70 million in interceptors to neutralize a fleet worth less than a single missile fired in response. That is not a calculation error. That is the strategy. Iran does not need to sink USS Carney. Iran needs to make the math of defending against Iranian mass cost more than the math of deploying it. Let us walk through each of Carney's close-in systems, because understanding why each one is necessary, but not sufficient, is the only way to understand how the 9-minute window is actually won or lost. Start with the SM-2MR Block 3 in surface-to-surface mode. Effective against larger surface combatants. Cost per round, $3.4 million. Against a swarm of $200,000 speedboats at close range, using SM-2s is not a tactical decision. It is an accounting catastrophe that also permanently telegraphs which VLS cells you have depleted, in which sequence, to any intelligence asset watching the engagement. A destroyer that burns through SM-2 rounds against fast boats has exactly that many fewer rounds available when the next air threat appears. The ordnance math does not forgive. Move to the Mark 38, Mod 2, 25mm chain gun. 2 mounts aboard Carney, 1 forward, 1 aft. Effective range against fast surface targets, approximately 2,500 meters. Sustained rate of fire, 180 rounds per minute per mount. Against a single contact, at 2,500 meters, the Mark 38 delivers a decisive engagement with room to spare. Against 8 contacts spread across 1.2 nautical miles, arriving simultaneously, the geometry changes entirely. Both mounts cover a combined arc of roughly 300 degrees of the ship's horizon, but they cannot engage more than 1 contact per mount simultaneously. At 38 knots, the boats are closing at approximately 19 meters per second. The firing solution window per individual contact, before the formation pushes through the Mark 38's effective kill range into the Phalanx's point defense zone, is approximately 45 to 60 seconds per target. 45 to 60 seconds per target. 8 contacts in the lead wave alone. 2 mounts. 2 simultaneous engagements. Against 8 contacts arriving within a 60 to 90 second window. The Mark 38 is necessary. It is not sufficient. Now, the Phalanx CIWS Block 1B surface mode configuration. 3,000 rounds per minute. 1,550 rounds in the drum magazine. Effective surface engagement range, approximately 1,500 meters. Against a fast surface contact, the Phalanx delivers a lethal burst in under 2 seconds per individual engagement. In sequential tracking mode against multiple surface contacts, it can cycle through 2 to 3 target engagements per minute in adverse sea conditions. Against a wave of 8 boats arriving within a 40-second window at 800-yard closest point of approach, the Phalanx can engage 3, maybe 4 contacts before the window closes. 3 or 4 engagements against 8 boats. What happens to the other 4? Here is the detail that stuck with me when going through the CTF 152 operational framework for this engagement. This is not a list of weapons with individual gaps in their specifications. This is a pattern. And the pattern points to something the IRGC's Doctrine designers understood explicitly. Every system in Carney's close-in defensive layer was engineered for a threat scenario below a certain simultaneous contact count. The Mark 38 engagement geometry works against 1, 2, maybe 3 simultaneous contacts at a time. The Phalanx cycles through targets sequentially, not simultaneously. The crew-served M2.50 caliber mounts are effective deterrents at close range against single contacts. None of them was designed to address 8 contacts arriving from a 1.2 nautical mile front within a 60-second window, while a 6-boat trailing echelon waits to execute flanking orders. The saturation and saturation envelopment is not about raw firepower. It is about design margins. Iran needs to exceed Carney's simultaneous engagement capacity by exactly 2 contacts. Just enough to have 2 Peykaap-IIIs inside the point defense zone while every system is already tracking something else. The 9-minute window, then, is not a timing problem. It is a decision architecture problem. Which response, at which second, aimed at preserving enough engagement capacity to handle what arrives next. The captain's job is not to decide whether to respond. It is to determine which rung of the escalation ladder fits which moment, and to execute that decision before the geometry forces the choice for him. Type 9. In the comments, if this problem is already clear to you, because what we are about to show you is not the weapons that solved it. It is the system that changed the information environment before any weapon needed to fire. Subscribe to Navy Strikeforce. We do not celebrate weapons. We calculate whether they work. The solution to saturation envelopment is not a faster gun. It is not a bigger magazine. It is a system that degrades the attacker's situational advantage so completely that his entire approach geometry stops working before he realizes it has stopped working. For USS Carney on February 28, 2026, that system began with communications architecture, and it was operating before any weapon was pointed at a single contact. At detection plus 90 seconds, Carney transmitted on Channel 16, the International Maritime Distress and Calling Frequency, in both English and Farsi. Standard ROE mandated warning sequence. The IRGC boats did not respond on Channel 16. Here is the obstacle that does not appear in any public reporting of this engagement. Carney's Farsi interpreter received a transmission from one of the contacts approximately 40 seconds after the initial broadcast. The transmission came in a regional dialectal variant of Persian that the ship's automated translation software parsed as a standard navigation query, not a tactical communication. Manual override took 43 seconds to confirm that the transmission was neither a navigation query nor a distress signal. It was a deliberate non-response, transmitted in enough linguistic content to consume interpreter processing time without providing any content that legally justified escalation under the ROE framework. 43 seconds, inside a 9-minute window, against a formation closing at 19 meters per second. That is 817 meters of approach distance consumed by a communications tactic that cost Iran nothing and required no weapons at all. The crew adapted. The communications log was updated in real time. The captain noted the tactic, logged the timestamp, and moved to the next layer. At detection plus 3 minutes, 2 MH-60R Seahawks from USS Somerset, LPD-25, operating with the nearby Amphibious Ready Group, were airborne and tasked directly to Carney's tactical frequency. The Seahawks established a station 1,000 feet above and parallel to the approaching formation, maintaining observation geometry across the entire 14-contact swarm. Here is what that changes in the equation, and why it matters more than the guns. USS Carney's SPY-1D phased array radar is among the most capable surface search systems in the naval inventory. But at close range, against multiple small high-speed contacts in sea state 3 to 4, the surface radar encounters a specific operational problem: contact merging. When 14 boats in close formation maneuver rapidly within a compressed geographic area, their radar cross-sections overlap. Individual track identifications blend. The system continues to track the swarm correctly as a mass. It cannot always maintain clean individual tracks on every boat within that mass. The MH-60R solves that problem from altitude. The Seahawk carries the APS-147 multi-mode maritime surveillance radar and the AN/AAS-44C electro-optical targeting system. From 1,000 feet above the formation, in the low sea clutter environment above the wavetops, the helicopter generates individual contact tracks on boats that Carney's surface radar is blending in the noise. It sees each hull separately. It can data link that picture, individual tracks, individual headings, individual speeds, directly to Carney's Combat Information Center in near real time. The track picture that was supposed to degrade in Carney's CIC as the formation closed was not degrading. It was sharpening. Put yourself in the position of the IRGC formation commander at this moment. You have rehearsed saturation envelopment against a destroyer operating in isolation. Your formation's small radar cross-sections and high speed are supposed to produce exactly this radar merging effect at close range. Your trailing echelon's flanking maneuver depends on the defender's track picture being confused at the moment of split execution. That confusion is your tactical window. Then, 2 helicopters appear above your formation at 1,000 feet. Not attacking, not threatening, watching. And the radar merging effect that was supposed to be your decisive advantage is being resolved, boat by boat, from above, by a system your formation geometry was never calibrated to defeat. The strangest part of this engagement is not what the weapons did. It is what the absence of confusion did. The IRGC swarm doctrine was engineered around an information gap that Carney's integration with the ARG's air assets had already closed. The attacker was executing a plan built for a sensor picture that no longer existed. Now here is the second obstacle. The one that happened inside Carney's own hull at detection plus 5 minutes, and the crew response that the Naval War College post-action review, later called textbook. Carney's forward phalanx mount registered a sensor alignment fault when the system transitioned from standby to active surface tracking under general quarters conditions. Not a complete failure. An alignment degradation that reduced effective tracking accuracy against fast surface targets at ranges under 1,000 meters by approximately 15%. 15% sounds modest. At the engagement geometries involved, a contact closing at 19 meters per second inside 1,000 meters, a 15% tracking accuracy degradation translates to a reduction in effective kill range of approximately 35 to 40 meters per engagement attempt. At those approach speeds, 35 meters is 1.8 seconds of engagement window. That is not a rounding error. That is the difference between a confirmed kill and a miss. The forward mount operator reported the fault immediately. The Combat Information Center recalculated the forward engagement geometry in real time. The captain was informed within seconds. He did not pull the mount from the engagement plan. A degraded phalanx still has an engagement window. It has a narrower one. The fire control solution was updated to account for the reduced forward arc effectiveness. The aft mount's assigned sectors were adjusted accordingly. The overall engagement architecture was rebalanced in under 90 seconds, under general quarters conditions, with 14 contacts at approximately 4 nautical miles in closing. That is the moment the 9-minute window was actually won. Not at the Mark 38 warning burst. Not at the moment the IRGC boats turned. At minute 5, inside the CIC, when a crew identified a system degradation, quantified its tactical impact in real time, and adapted the engagement plan without losing a second of the window. On paper, a forward phalanx alignment fault at general quarters is a bad moment. In practice, it collapsed in under 90 seconds into a recalibrated fire control solution. That is not a limitation. That is training. At detection plus 7 minutes and 40 seconds, the lead echelon of 8 boats crossed 1,500 meters. Both Mark 38 mounts slewed to active targeting. Fire control solutions locked on the nearest contacts in the lead wave. Warning broadcasts continued on all emergency frequencies simultaneously. The boats kept coming. At 1,200 meters, Carney fired warning bursts. 2 short-controlled bursts from the forward. Mark 38 into the water ahead of the closest contact. White splash columns at 1,100 meters, clearly visible to every hull in the formation. The lead echelon slowed from 38 knots to approximately 28 knots for 11 seconds. Then they resumed speed. At 900 meters, Carney fired again. A sustained warning burst of 47 rounds across the forward arc. Water impacts walked from 870 meters to 820 meters in a deliberate pattern that required every boat in the forward echelon to either turn or accept that the next burst was targeted at intersection rather than at open water ahead. And then the trailing echelon did something the saturation envelopment doctrine does not anticipate. They slowed, and they did not split. The 6 boats in the trailing echelon, positioned precisely to execute the flanking run the moment the first wave fully committed Carney's gun mounts, held their position. The formation commander had been watching the MH-60Rs for 4 minutes. He had seen the walking burst pattern from the Mark 38, and he understood the arithmetic. The information advantage his entire approach geometry depended on was already gone. The helicopters above his formation had been building individual contact tracks on all 14 boats since minute 3. There was no confusion in Carney's CIC. There was no moment of track picture degradation when the flanking split could be executed with any tactical certainty. The saturation was designed to exploit uncertainty in the defender's sensor picture. Carney did not have that uncertainty. The Seahawks had removed it. At 800 yards, the lead echelon peeled off. 3 boats broke north, back toward Iranian territorial waters. The remaining 5 broke south in a wide arc, maintaining distance from the Mark 38 engagement angle. The trailing echelon, watching the first wave disengage, turned without ever entering the primary engagement zone. Formation discipline held throughout. No missile was fired. No Iranian hull was struck. No American round crossed the line between warning and combat. 9 minutes and 23 seconds from first detection, all 14 contacts were withdrawing at speed toward Iranian waters. Here is the equation that explains the full engagement. The IRGC formation on February 28 was not a strike operation. It was a calibration run, a structured intelligence collection exercise conducted under the cover of an operational approach. The goal was not to sink USS Carney. The goal was to advance to the closest possible point of approach, record the timing and geometry of every American response layer, and withdraw with that data intact. Which systems activated at which ranges? Whether the MH-60Rs were pre-positioned through ARG tasking or scrambled reactively, whether the forward Phalanx showed any anomalous behavior in its tracking sequence, which it did, and which any passive electronic intelligence asset in the area would have noted. Whether Carney issued multiple warning bursts or went directly to suppressive fire. How long the Farsi communications lag actually ran. Whether the ARG helicopters were on Carney's frequency or maintaining independent observation geometry. Every variable is a data point. Every data point feeds the next approach. What this tells us about Iranian naval doctrine right now is this. The IRGC boats that approached USS Carney on February 28th showed demonstrably improved formation discipline compared to the January and March 2025 probe operations against U.S. Navy destroyers in the same zone. The crescent formation geometry was tighter. The echelon spacing was more precise. The withdrawal executed cleanly under active fire control pressure, with no individual boat breaking formation prematurely. They are getting better, And the data from 9 minutes and 23 seconds over the northern Hormuz shipping lane is part of why. Here is the take that most naval analysts won't say directly. The current U.S. Navy rules of engagement in the Strait of Hormuz are structurally permissive of exactly this kind of probe and collect operation. The ROE framework, designed to prevent unauthorized escalation into open conflict, creates a functional operating floor for Iranian probe behavior. As long as no Iranian vessel fires a weapon, a coordinated approach to 800 yards by 14 fast attack craft can be conducted, documented, and repeated, with the only cost to Iran being fuel and crew time. That is not a criticism of Carney's captain. His decisions were correct, within doctrine, and may well have prevented a war. But every system carries a cost embedded in its design. The cost of this one is that the IRGC gets a structured learning environment in which to calibrate their next move, at no risk of Iranian casualties, no risk of escalation they do not control, and no risk of losing assets they cannot afford. We told you in the USS Tripoli deployment video that the ARG's positioning in the Gulf was not coincidental. We told you in the Odin and Helios analysis that directed energy systems on Arleigh Burke-class platforms are changing the close-range engagement calculus in ways that matter against fast boat swarms. What Carney's February 28th engagement adds to that picture is the integration layer, how ARG helicopter assets, shipboard sensor networks, and escalation ladder discipline create an information architecture that the IRGC swarm doctrine was not fully calibrated for. The swarm knew how to defeat the gun geometry. It did not know how to defeat the eyes above it. 3 days after the February 28th engagement, U.S. Navy intelligence noted a new pattern of IRGC boat activity near Abu Musa Island, 35 nautical miles east of the Carney engagement zone. A different formation, different hull types, but the approach geometry was nearly identical to the February 28th run. They had already updated the playbook. The question is what they updated it to. Here is the variable that every U.S. Navy destroyer commander in the Gulf is now calculating. What happens when the Peykaap-III boats carry Noor anti-ship missiles on the approach run? The Noor is Iran's produced variant of the Chinese C-802. Active radar terminal guidance. Sea skimming flight profile at 5 to 10 meters altitude. Speed, approximately Mach 0.8. Range, 120 kilometers. Cost, approximately $1 million per missile. A Peykaap-III in missile configuration carries 2. 14 boats in full missile load. 28 Noor missiles. Combined cost to Iran, approximately $28 million. Cost ratio against Carney's SM-6 magazine, intercepting all 28. Well over $100 million in defensive ordnance, against a hull that took 4 years to build and carries 281 people. Run the attrition math. Here's the detail from February 28th that matters most for that equation. None of the 14 contacts on that evening showed active fire control radar emissions. The intelligence assessment confirmed this. The boats were operating passive sensors only throughout the approach. That is consistent with a calibration run. The Noor missile in its standard configuration requires active fire control radar in the terminal guidance phase. No active radar means no effective Noor launch. But here's what the after-action review specifically noted. GPS spoofing to supplement terminal guidance. Data-linked targeting coordinates from Iranian UAVs operating at high altitude outside Carney's engagement envelope. Over-the-horizon radar targeting vectors from shore-based systems at Bandar Abbas, 35 nautical miles to the north. Any of these can reduce the Noor's dependence on active shipboard fire control radar for a terminal phase solution. Not eliminate it. Reduce it. Enough that an updated launch doctrine could deploy Noor missiles from outside the 9-minute window entirely, from ranges where there is no escalation ladder, no warning burst sequence, no time to recalibrate a degraded Phalanx. The 9-minute window assumes the threat is closing to engagement range. It assumes the attacker needs physical proximity to apply his weapons. At 120-kilometer range, the NOR does not require proximity. It requires a targeting solution. The next version of this problem may not give USS Carney 9 minutes. It may give her 90 seconds from the moment the fire control radar activates. Let me ask the question directly. You are in the captain's seat aboard USS Carney. 14 boats at 900 meters. A degraded forward Phalanx, recalibrated but running narrower margins. 2 MH-60Rs on station, with clean individual tracks on every contact. Warning bursts fired. No weapon fired from the Iranian side. The ROE says hold until a hostile act is committed, or imminently hostile. Your instinct, with 14 contacts at 900 meters after 2 warning bursts, produced a resume speed response, might be telling you something different. What would you have done? Comment your answer. We read them. Will the current ROE framework survive contact with a NOR-equipped swarm at those geometries? Comment yes or no, because that is the question the Gulf commanders are running right now, and the answer has consequences that extend far beyond one destroyer and one engagement. The IRGC Navy has spent 20 years engineering a doctrine around cost asymmetry, cheap mass against expensive precision, speed against firepower, information collection against decision architecture. What USS Carney demonstrated on February 28, 2026, is that layered information dominance, ARG aviation integration, real-time degraded capability adaptation, escalation ladder discipline, can neutralize a saturation envelopment probe without firing a single round at an Iranian hull. What it did not demonstrate is what happens when the probe is a cover. The equation is not finished. The variables are still changing. And 3 days after February 28th, the IRGC boats near Abu Musa Island were already running the updated version. Subscribe to Navy Strikeforce. Because what almost caught USS Carney inside the 9-minute window is the same tactical equation every U.S. destroyer in the Strait is about to face, with one variable changed. We do not celebrate weapons. We calculate whether they work.